Okay, well that one was running out of time and uploading. I couldn't figure out why my answer on my other sheet was wrong. It's because I couldn't make it out. I thought it was saying 0.4 and it was saying 1. It was my eyes, and I think I lost a 0 there after all of that. So 0.11, and it is a negative. What does the negative mean? The negative means it's going down because the one going down is larger. So now that you have the total in the y direction and the total in the x direction, now all that's left is that you draw it. So one's going to the left and one's going down. Okay? And so the force on A then is going to be like this. So this is going to be FQA. This guy is the 0.003428. And this one is the 0.011338. Okay, so you're going to square them, add them together, take the square root, and find the theta. And when you do, you get an FQA. So this is the total force on A, to be 0.01187 newtons, and at an angle of, the way I have it drawn, 73.21 degrees, and that will be counterclockwise from the negative x, right? Because it's going down. So that's the first part of 7. Now the good news is the next two parts aren't as bad. So second, if we do B, then on B, if we look at the forces, A is attracting B, so it's pulling it up. Okay, and this will be the 141. So this is 0.0141 newtons going up. And C is also attracting B, so it's pulling it over. And BC was the 72. BC, oops, that's going to be 0072. Now the good news is they're at right angles to each other. So slide one up or the other over. I'd probably bring this one over. And my resultant, which will be FQ on B, that I don't have to do any components to, I can just square, add together, take the square root, and find the angle. So FQB should end up being 0.01583 newtons at an angle of, I wanted to make sure my angle matched, 62.95 degrees, and that would be CCW positive X. And I said B and I wrote A there. I'll fix it in a sec. This is really on B. Okay, so I told you the second one was easier. And the third one's going to look a lot like A. So the third is on C. Now the good news is we've already found its components, right? So I need to move it over a little to give myself enough room there. Okay, so if I draw C up here, then B is attracting it. So B is going to be pulling it this way. And if you remember, FQBC was the 772, so this is BC, 0.0072 newtons. And A is going to be repelling it. A is going to be pushing it down. And again, we can break A up into its components, its X and Y. So this is the 349, 0.00439 newtons. Theta, this will be FACX, and this will be FACY. This angle should be that angle. And so this will be the 38.66 degrees. Now the good news is we already found the X and Y. We found them right here. So we don't need to find them again. Okay, so the X and Y are the same. And so now we can just do our total. This time our total in the Y is going to be easy. Our total in the Y only has the 1, and it's 0.00 0.274 newtons. And our total in the x, we need to subtract. So our x component is going to the right this time, 0.03428. This guy's down. Newtons. And then minus the one to the left, 0.072 newtons. So we get our total in the x to be 0.003772 newtons, and it's going left. So then when we draw it, we have down and left. So down, left. And so this will be our FQC. Square them, add them together, take the square root. So FQC should end up being 0.00466 newtons at an angle of, and my down is actually bigger. This is not drawn to scale. I'm just trying to decide if I did it from the right one. 3654. Clockwise, yeah, I think it's 54 degrees, and that will be clockwise negative x. Or is it 36? Which one's bigger? My x is bigger. It is 54. Okay? And that's the end of 7. Aren't you glad that you only had 1 to do like that? I promise 6 and 9 are better. All right. So going back to 6 then. 6 says, a single isolated proton is fixed on a surface. Okay, so here's my surface. We have a proton fixed here. And where must another proton be located in relation to the first so that the force of repulsion would just support its weight? So we're going to put a dude up here. Fg is going to be acting down on this dude. Fq is going to be acting up. And if it supports its weight, it means that Fq minus Fg must equal 0, sum of the forces in the y. Or Fq must equal Fg. So KQQ over R squared must equal mg. And they're saying where, so we're looking for the R. So R squared must be equal to KQQ over mg. K, 9 times 10 to the 9th, Newton meters squared per coulomb squared. Charge of a proton, I gave you the first day of this unit, 1.602 to the negative 19 coulombs, and there's 2 of them, so I'm just going to put a squared there. Charge on a proton, 1.673 to the negative 27 kilograms, times 9.81 meters per second squared. Remember, that's going to be R, and you're going to have to take the square root, and when you do, you get 0.1186 meters. Okay? That's number 6. Told you it was easier. Number 9. Number 9 has a pith ball hanging down, and I had talked about this one, so we're looking in the video of the day when I assigned it. So you're looking at this pith ball that's out at an angle. It has an Fg going down. It has an FQ from the other pith ball over here acting out. And it has an FT acting up. And this FT has 2 components. It has an FT in the y direction and an FT in the x direction. And we know our angle, it told us the angle up here was 20 degrees, which means the angle down here is 20 degrees. So you're going to do sum of the forces in the x has to be equal to 0. So it'll be FTX will be equal to, that's really a Q, FQ. So FT sine theta is equal to KQQ over R squared. Okay, if we do sum of the forces, going to run out of time. In the y direction, it also has to be 0. So FTY has to equal FG, or FT cos theta has to equal mg. So I would rearrange this for FT and get mg over cos theta. And then I would sub it in up here. So we would have mg over cos theta times sine theta equals k